King Kong banging on your chest. You could beat the
Okay, let us check the first example under the chi-square test. A group of 150 nursing students who participated in the health survey were asked whether or not they were on a diet. The response by gender are as follows. Now, if you look at this question, they were asking them, are you on diet? Yes or no? That's just dichotomous response. Yes, I'm on diet. No, I'm not on diet. Okay, what type of gender are they, male or female? So now let us now look at this. We have the diet and no diet. Then we have the male, we have the what? We have the female. So those who responded that they were on diet and they were male, they were 14. The same thing for not on diet, 59. Then we have the female that are on diet. We have 25 female that are on diet. And then we have 52 female that are what? That are no diet. Now, if we check this, the total sum of this, the row wise, 14 plus 59, this one will give us 73. And then 25 plus 52, we are going to have 77. The same thing goes with this. If we sum this, 14 plus 25, we are going to have 39. 59 plus 52, we are going to have 111. Then the grand total, the sum of everything is what? Is 150. Now this is not the question. Does this data suggest an association between sex and diet at alpha is equal to 0.05%? Now, what did they ask there? That is there any association between what? Between the sex and the diet. That's what they are saying. Now, the hypothesis, we're going to state our hypothesis. The first hypothesis, which is the non-hypothesis, that there is no association between the sex and the diet. That's the non-hypothesis. Then the alternative hypothesis will have the what? There is association between the sex and the diet. So that is what we want to test for. Now, to calculate the chi-square, initially we have that formula for the chi-square. Now we need the expected. Now the formula to calculate the expected is the row total times the column total over the grand total. Now what do I mean by that? Let us look at the cell 1. Let us look at observation 1. This one is observation 1, in row 1, and what? In column 1. So we want to find the expected for this. Now if we check this, what is the sum of this total row? We have 73. So that is row total. Then what about the sum of the column total? We have 39. And then the grand total is 150. That's why we have 73 times 39, then divided by the 150. Then when you do that, we are going to have 18.98. That is for what? That is for the first set. Now we move to the second set. The same thing. The row total then times the column total. The row total here is 73 times 111. Then divided by 150. We are going to have 4.02. And then the next one is, which is what? We are in row 2, column 1. So the total row here is 77, multiplied by the total column here, which is 39, then divided by 150, which is the grand total. Then we have 20.02. The same thing goes for the last row, which is what? The row total is 77, and then the column total is 111. When you divide it by 150, we're going to have 56.98. Now, the degree of freedom for this chi-square, how many rows do we have? We have just two, row 1 and row 2 minus 1 times the column 1, diet, column 2, no diet. That is 2 columns. So minus 1. So 1 times 1 will give us 1. Now the chi-square now, don't forget that the formula for chi-square is the summation of what? Observed minus the expected square all over what? All over the expected. Now the first observation here is 14. So 14 minus is expected. The expected is 18.98, which is this, square it divided by the same expected. Plus, we move to the next one, the cell 2. We have 59. The observed is 59 minus the expected, which is 54.02, divided by what? 54.02. Then plus the next one is 25 minus 20.02 square, divided by, we're going to put square to this, divided by 20.02. And then the last one is the 52 minus is expected. The expected is what? 6.98. 56 3.98 square, then what divided by its expected. By the time we do summation of this, we are going to arrive at the high square of what? 3.4398, which is our what? Our calculated value. So after this, we are going to what? We are going to put this in our calculator to get our probability value before we can make this to do what? To make conclusion. So now we are moving to the what? To the next one. All right. So now we've gotten our what? Our calculated chi-square to be 3.4398. Then we have chi-square calculated one on the table. We have the alpha, then we have the degree of freedom, which is one that we calculated the other time. Now we are going to have the chi-square of 0.05 over this. If you want to check it on your statistical table, we are going to have what? 3.841 for the what? For the what? For the calculated. Now there is what we call the p-value. The p-value is the one that we normally use to compare with the alpha, which is what how the is telling us about the evidence that we have against the non-hypothesis of rejecting the non-hypothesis. That is, if the probability value is less than the alpha, which is the significant value, then we reject our non-hypothesis. Otherwise, we do not reject. If we are going by the table, it means that the calculated value must be greater than what? The tabulated value. If the calculated value is greater than the tabulated value, then we reject our non-hypothesis. Then we make a conclusion. But now we are using what? We are using the probability value. The probability value of this is 0.999971, which is what? Which is greater than what? Which is greater than the alpha. So if you are the type that you normally use the Casio FX99IES Plus, if that is your calculator that you are using, I want to teach you how to get the probability value on this. The first thing is to press mode. Once you press mode, you will see number one compound, you see complex, then you see number three called start. Just pick three start. Then after you press start, then you go back to your AC. Then by the time you check the heading of the calculator, you will see what they put star, which is STAT. Now after that, that means that your calculator is now in statistical what? Form to what? To carry out any statistical analysis. Now press shift. Once you press shift, then if you press 1 on at the edge of that one, you will still start. The shift is telling us that you want to use the second function of this. Once you press this, you are going to see number 1 type, number 2 data, number 3 sum, number 4 var, number 5 district. That is what we call distribution. So you pick 5. Once you press that 5, you are going to have number 1 to be P, number 2 to be Q, number 3 to be R, and then number 4 to be T. But what we need in this situation is the probability, which is 1. So once you press 1, it's asking for the value of the test statistic that we have, which is what? 3.4398. 3.4398. That was the test statistic for the chi-square that we have. So once you press is equals to, it will give you the probability value, which is 0.99971. So it is the probability value that we are going to compare what? With our alpha. So if the probability value here, the p-value is less than the what? The alpha, which is 0.05, that means that we are rejecting what? The non-hypothesis. But otherwise, if the p-value is greater than the alpha, that means that we do not what? We do not reject our non-hypothesis. So in this scenario, we are not rejecting the non-hypothesis. So the non-hypothesis is being accepted. Then we make what? We make conclusion. Now that the non-hypothesis is being accepted, that means that we don't have sufficient evidence what? To conclude that there is association between the nursing student and what? Between the nursing student sex and diet. Let me take it again. We don't have sufficient evidence to conclude that there is association in the sex and what? And the diet among what? Among the nursing student. So we can conclude that. Now the other formula to calculate chi-square that we stated the other time is we have what? We have the capital N, which is the what? Which is the total what? Which is the grand total. In this case, is 150. Then we have what? The cross product. This one multiplied by this, and this multiplied by this. So by the time we do that, we are going to have 14 multiplied by 52. Then we have what? Minus 25 multiplied by what? By 59 squared. Then divided by, we have 73 times 77 times 39 times 111. So by the time we do justice to this, we are going to arrive at the chi-square the calculated value to be what? 3.4398, which is the same thing as the previous one. So any of the formula is what is correct. So you can also apply this and put this inside your calculator. Don't forget, if you are using this type of my calculator, just press mode. Once you press mode, then once you press mode, once you press mode, you will see compound, you will see complex, then you will see start. Start is 3. Once you press 3, that means that you put this calculator in the function to take what? To perform any statistical analysis. Now put it back at AC. We have the AC. So at the edge of that your calculator, you must check it. Is it in statistical mode? Is it in start mode? Once you have STAT, that means in start mode. Then you press shift. Once you press shift, you will press 1. Immediately you press 1, other function will pump up, which is number 1 is type, number 2 is data, number 2 is data, number 3 is sum, number 4 is var, then number 5 is distribution, which is what we need. Once you press that 5, we have what? Number 1 is P, which is the probability. Once you press 1, it's asking for the value. Just press 3.4398. Then it will give you your answer, which is 0.99971, which is the probability value. Thank you so much. See you in the next class. Thank you.